Welcome back. We are still in lesson two. Give the models a chance, talking about probability models. We're soon going to set one up and then talk about what is a uniform probability model and what is a non uniform probability model. All right, we've completed the getting started. Let's go on to activity 2.1 using probability models. I'll go ahead and start reading. Please follow along and annotate. It says, Jorge and Tristan are training to be magicians and are working on a card trick. They have 5 cards of different colors: red, blue, yellow, green, and purple. They are discussing the likelihood of an audience member picking each color, assuming that they can't see the card's color. Question number 1 says, list the sample space for choosing a card. Now, the sample space, remember, are all or is all of the possible outcomes in this event, in this experiment. So here it tells us in the description that there are 5 different color cards, and I went ahead and just drew those out for you because if I've got the tools to, why not? So now we have a visual of the different cards that are in this stack. So what I want you to do is I want you to take about 3 minutes, no more than three, to list out the sample space, for number one, and then also to complete number two, where it asks you what is the probability of selecting each card. Write the probability for each in the table. So for red, blue, yellow, green, and purple, you are using a fraction to describe and to write down that probability. All right, 3 minutes to do number one and two. Go ahead and pause here. Alrighty, let's compare answers. So the sample space, remember you'll usually see sample space notated within those squiggly brackets. So that's why I did those squiggly brackets to the side of my sample space. And in the sample space, we already know there is a red, a blue, a yellow, a green, and a purple card in this stack. And then the probability for each of those, well, as you can see, is 1 out of 5. Remember, the description says there are only 5 cards of different colors. And each of those, it doesn't say a number because there's only one of those. It says a red, blue, yellow, green, and purple. And as you can see in my picture too, there are only one of those cards. This is the stack. So for each of those, I know the probability is 1 out of 5 or 1/5. Let's continue reading. Below it says, when solving a probability problem, it is helpful to construct a probability model. Get ready to highlight. A probability model, highlight this, is a list of each possible outcome along with its probability. So it is a list of each possible outcome along with its probability. Probability models are often shown in a table. So as you can see in number 2, you just created a probability model. You also created a probability model in the getting started and you just didn't know it. So really easy to create. Let's continue reading. A probability model will list all of the outcomes, which will be greater than 0, but less than 1. The sum of all probabilities for the outcomes will always be 1. Well, let's test that theory. Let's see. For the probability model we just made, let's add all of these fractions. So if I were to add all of these, I know I'm adding fifths, so my denominator stays the same. Let's see how many fifths I have. 1, 2, 3, 4, 5. I have 5/5. Oh, look at that. And 5/5, we know, simplifies to be 1 whole or 100%. Question number 3 says, why is the sum of the probabilities in a probability model always 1? I want you to take about 1 minute and 1 minute only to discuss this question with your neighbor. If you don't have a neighbor, talk to Casper, the friendly ghost. 1 minute. Pause here. Alrighty, let's look at number 3. So your answers may vary, but you could have said something to the effect of, the probability is always 1 because the model lists every possible outcome that can occur, so they must add to 100% to account for all outcomes, meaning there is a 100% chance that I'm going to get one of those outcomes, right? There's a 100% chance that I'm going to get one of them because they all add to 100% of the experiment. Alrighty, let's move on. Question number 4 says, Tristan claims in any probability model, the probabilities for all outcomes are equal to each other. Jorge disagrees and says the sum of all probabilities is 1 for any probability model, but that does not mean that the probabilities of all outcomes are equal. Who is correct? Explain your reasoning. So essentially, what Tristan is saying is that all probability models are going to have equally likely outcomes, similar to this one. But think about what we created in the getting started. And then Jorge says, I respectfully disagree. Actually, the sum of the probabilities is always going to be 1, just like it was in our last activity or this activity. And he's also saying that that doesn't necessarily mean that all of the probabilities will be equally likely or will be equal to each other. So think about who is correct here. Is it Tristan or is it Jorge? I want you to take 1 minute and 1 minute only to write your response. Who is correct? Pause here. Alrighty, let's see who's correct. If you said Jorge is correct, you're absolutely right. Jorge is correct in this situation because, yes, he's right. All models will have a sum of 100%. We just talked about that. And also, not all probability models will have equally likely outcomes, not events, outcomes. Typo, y'all. Just like the getting started. So let me show you what I mean. So in this event, yes, Tristan was right. These ones have an equally likely outcome. The pennies, are they pennies? No, sorry, the cards. But in the getting started, the outcomes were not equally likely. Okay, we saw that the quarter had the least likely chance, and the nickel had the greatest chance or probability. So in this case, Jorge was correct. Alrighty, let's continue. To sum up this activity, we're going to highlight and understand 2 new vocabulary words. So let's read. It says, a uniform probability model. Let's go and highlight that. I'll use blue. A uniform probability model occurs when all probabilities in a probability model are equally likely to occur. When all the probabilities in the model are equally likely to occur. Each color card in the magician's trick had the same probability of being chosen. When all probabilities in a probability model are not equal to each other, it is called a non-uniform probability model. An example would be a weather forecast that states that there is a 30% chance of rain. This means that there is a 70% chance that it will not rain. The sum of these 2 probabilities is 1, but the outcomes do not have the same probability. Also, a non-uniform probability model, and I'll keep referring to what we just did or what we've done so far, is what we did in the getting started. Each of these coins has a different probability, so it is non-uniform. Alrighty, that sums up the learning for this activity. I will see you in the next video.